Hi, in this video we'll be discussing modeling constraints, the no-slip condition. We'll be discussing time-dependent rotation variables, slipping versus no-slipping, how to constrain velocity, and checking your assumption. The problem with rotating disks is that there are two time-dependent variables, theta of t and x of t, that are independent of each other. However, they can be related back to each other if we assume that the disk is not slipping. We know that at the point of contact, the velocity of the disk and the ground will be the same, which is to say that the velocity of the disk at that point will be equal to 0. So we know this is not how a disk typically moves, and that there is a relationship between the angle of rotation, theta, and the distance it has traveled in the E1 direction, assuming that it doesn't slip. So we're going to make this no-slip assumption and then check if it is true. This is what it looks like when a disk is rotating without slipping. However, there is a kinematic constraint on the velocity at the point of contact, which is not something that we can build into our position vector like we build most of our kinematic constraints, which is why we're going to have to do this in the modeling and constraints section. So we have our position vector. We're going to differentiate for our velocity vector, and then plug in our spatial variables at the point of contact. So we're going to plug in r and minus pi over 2. And we know that at the point of contact, the velocity is equal to 0. Also note that if we just rotate the n and m vectors, we can see that the m vector at the point of contact is just equal to E1. So we plug that in, and then we are going to dot it with E1, and we're going to have a relationship between x dot and r theta dot. So then later on in the problem, what we're going to have to do is check the no-slip assumption. So if x of t is equal to r theta dot, then our assumption of no-slip is true. However, if x dot of t is greater than r theta dot, this means that our assumption is not true and the disk is slipping. The way I like to think about this is basically it's moving in the E1 direction faster than it's rotating.